Given question, determine ratio of loads P and Q for which the system is in equilibrium. Inclined surfaces are smooth.
For this system in equilibrium, we have to first draw the free body diagram. There are two blocks with loads P and Q, which are attached to the pulley with the help of string. We have to show these loads which will act in vertically downward direction passing through the pulley. So I will show here the load P and this is the load Q. The surfaces are smooth. That means when these blocks slides on the inclined surface, there is no any friction. The blocks are in contact with inclined surface. So we have to show normal reaction. So the reaction is perpendicular to the inclined surface and passing through the center of the block. So we will show here normal reaction N1 and here is normal reaction N2. If we observe these two inclined surface, that is this inclined surface is having angle theta 1 with horizontal and this inclined surface is having angle theta 2 with horizontal. If we consider this block P will slide in downward direction along the inclined surface, then at the same time this block Q will move in the upward direction by the same magnitude of the displacement. So I will show here the displacement is delta S. So direction is in the downward direction. Now at the same time this same displacement for this block Q but in the opposite direction, that is in the upward direction. Because these two blocks are connected through the same string. Now if we observe this delta S is parallel to the inclined surface. This N1 and N2 is perpendicular to the inclined surface. So if we observe this P and Q, these two components are in vertically downward direction. So we can resolve this P and Q into two components. One component parallel to the inclined surface and other component perpendicular to the inclined surface. Now if we observe, here is N1 which is perpendicular to the inclined surface. So I will take line parallel to N1. Here is the component and other is parallel to the inclined surface. Here is the component. So we have to show arrows. Now in the same way for Q, one line parallel to the inclined surface, other line parallel to N2. So here is the direction. Now how to find out angle? So in between this horizontal line and inclined line, angle is theta 1. Now for this horizontal line, this vertical line is perpendicular. So I will make here mark. Now for this inclined line, this component is perpendicular. I will make here mark. So angle in between these two perpendicular line is same, that is theta 1. Now in the same way for horizontal line, this is the vertical line which is perpendicular, and for this inclined line this component is perpendicular. So angle in between these two perpendicular line is same, that is equal to theta 2. Now we will write its value. So this component is nearby to angle theta 1. So its value is P cos of theta 1. This is P sin of theta 1. Now in the same way, here this value for this perpendicular component is Q cos of theta 2. And for this Q sin of theta 2. From the diagram, we can say that these two blocks moves along the line parallel to the inclined surface. So there is no any movement which is perpendicular to the inclined surface. So we have to find out the components which are perpendicular to the inclined surface. So if we observe N1 is perpendicular to the inclined surface, so there is no any movement. That means displacement is equal to 0. So I will write here the displacement at N1 is equal to 0. Displacement at N2 is also equal to 0. q cos theta 2 is perpendicular to the inclined surface. So here it is 0, and p cos theta 1, it is also perpendicular to the inclined surface. So here displacement is 0. Now the next step is sign convention. So we will decide the sign convention for the remaining components. So we will say the displacement in the downward direction, which is parallel to the inclined surface, that is, we will consider the negative sign. So there are two directions. The components that are in the downward direction along the inclined surface, and components which are in the upward direction along the inclined surface. So I will show here. So here is the inclined surface. So this direction is downward direction. Now for downward direction we will use negative sign. And for upward direction, so this is the inclined surface. Now for this inclined surface, upward direction is this, and for this upward direction we will use positive sign. Now for this inclined surface downward direction, we will take line parallel to this and we will show the downward direction. So for this direction we will use negative sign. Now for this surface also we will take the opposite direction, that is, I will draw one line parallel to this, and if direction is upward then we will take positive sign. So this sign convention we have to consider. Now we will apply virtual work method. So virtual work method means what? Force multiplied by displacement. Now if we observe for perpendicular components, it is force multiplied by 0, it is 0. So we are not going to mention this. So we will only mention the parallel components. Now if we observe, we will consider this sign convention. So here is p sin theta 1. Direction is downward. So we will take negative sign. Minus p sin theta 1. Now for the displacement also we will use this same sign convention. So direction is in the downward direction, so we will take minus delta s. Minus delta s. So here we have to write by virtual work method. We are going to write this statement. Now next. So this is the first component. Now next is q sin theta 2. So if we observe direction, here is the direction. So we will take minus q sin theta 2 multiplied by displacement. So if we observe displacement, so here is the direction. So for this direction we will use positive sign. So here is only delta s is equal to 0. Now we will take delta s as a common term and it is not equal to 0. So if we transfer this to the right hand side, it will become 0. So this minus will become plus. So p sin theta 1 minus q sin theta 2 is equal to 0. So we have to take the ratio of loads. So p sin theta 1 is equal to q sin theta 2. So p by q is equal to sin theta 2 by sin theta 1. So this is the ratio of loads for the equilibrium of the system.